Welcome to Study Loop.
In this problem, we're told to consider a single-turn loop carrying a current of 4 amps. It's in the shape of a right triangle, and I've written a diagram down here with all the pertinent information. The loop is in a uniform magnetic field of magnitude 75.0 MT, and the direction is parallel to the current in the 130 centimeter side of the loop. So, for A, we were asked to find the magnitude of the force on the 130 centimeter side. To make sure I'm doing the right one. That'll be given by my force equals I times L times B times my sine of theta. So this will be my force will be equal to I times C times B times my sine of 90 degrees, and we can see that this force will be equal to 0. Next, we have the magnitude on the 50 centimeter side. So in this, the tangent of theta will be B over A. So theta will be our tangent of B over A. That'll equal tangent will be 120 centimeters over 50 centimeters. That'll equal 67.4 degrees. Okay, now we can do our force, same equation as our last page. A will equal 4.0, just need one here, 4.00 amps times, next I'll have 50.0 times 10 to the minus 2 meters times 75.0 times 10 to the minus 3 t's times the sine of 67.4 degrees. And this will equal 0.138 newtons. And that will be our answer for B. Let's go to C. C, the magnitude of the force on the 120 centimeter side. This will be similar. So this time, this is the angle I'm looking for. And if you go back to the beginning, I've got both these angles. And this will equal 22.6 degrees. And then we're going to plug this in. So our force of B this time will be 4 amps times 120 times 10 to the minus 2 meters times 75.0 times 10 to the minus 3 t times the sine of 22.6 degrees. So for this, and feel free to check my math on these, this will be 0.138 newtons. And finally, for part D. Here we're asked to find the magnitude of the force. So this will be the same thing here. So the right-handed rule, so the direction of the force due to side A, which I have labeled back on the first page, points out of page. And B points into page. So my net force will equal my force of A, which is positive, minus my force of B. And this will be 0.138. Were they both 0.138? Yes. This will be 0.138 minus 0.138 equals 0 is my net force. And we're finished.